Hello everyone, welcome to week 8 lectures. Our today's topic is bivariate statistical analysis, differences between two variables. So probably you can remember in the last week we discussed univariate statistical analysis that involved one variable. So today we will be discussing bivariate analysis. The next week we will also be discussing bivariate analysis. But our today's discussion is the difference between two variables, and the next week we will be discussing the relationship between two variables. And the week after we will be discussing multivariate analysis. So today we will cover chapter 22, bivariate statistical analysis. We have 5 learning objectives today. So first of all, we will see which bivariate test is appropriate under what circumstance, and we will be talking about 3 tests today: chi-square test, t-test, and ANOVA. So as usual, I will be posting separate videos on these learning objectives, and in this video I will be discussing the first learning objective: recognize when a bivariate statistical test is appropriate. So first of all, test of difference. What do we mean by test of difference? Put simply, when we test differences, we actually test a hypothesis that involving testing the difference either between two variables or between two groups involving a particular variable. Okay, let me give you some examples. Let's say you are measuring the difference between the profitability of Australian companies and profitability of US companies. So this is a test of difference. You may compare that what's the average profit of US companies and average profit of Australian companies, and you test are they different. Sometimes it might be possible that you test if a particular measure or a particular variable is different across the groups. For example, if you are testing a hypothesis that average income level of male is different from average income level of female. So that is a test of difference, because here you are testing if a particular variable like income is different for two groups. So this is examples of test of difference. Now bivariate test of differences. So in the last lecture, we also learned about the test of difference, but in that case, we examine that if a particular variable is different from a benchmark. But bivariate test of difference is, it involves testing the difference between two variables or difference between two groups involving a particular measure. In these tests or in this examination, typically one variable acts as a dependent variable and other variable act as a classification variable. Let's see some examples and try to find out what test is appropriate. This example is taken from your textbook. So first information that we have is average driver distance. There are 3 golfers, Dolly, Laurie, and Mel, and these are their average distance of their drive. So 135 is the average drive distance of Dolly, 150 is the average distance of Laurie, and 185 is the average distance of Mel. Now if your hypothesis is Laurie hits her drives farther than Dolly, so Laurie hits farther than Dolly. So what you will be actually testing, you will be testing that if the average distance of Laurie is different from average drive distance of Dolly. So what are the variables involved? The variable involved is, the main variable involved is the drive distance, that is ratio variable, and the golfer, that's nominal variable. So we will be using t-test to find out the difference between the average distance of these two golfers. And it is independent sample t-test. Independent sample t-test because the distance, drive distance of Laurie and drive distance of Dolly are supposed to be independent to each other. Then average 7 distance, for Dolly it's 140 and for Laurie it's 145. Actually, the average driver distance that was previously given is their average distance for their whole golf career. And this distance, average 7-wood distance, this is the average distance for their club, 7-wood. Okay. So for their club, it's 140 for dolly and 145 for lorry and 150 for male. Now, if you test that male hits her drive further than her 7-wood, so what you are testing is if the male's average drive distance is different from her club performance. That means, is her performance different when she plays for her club compared to her overall performance? So once again, the main ratio is the drive distance, that's a ratio variable, and club is the nominal variable. And again, we will use t-test because we are testing the difference between drive distance of male for her club and for her carrier. However, the main difference between the previous one and this one is that previously we used independent sample t-test because that was the test of average drive distance between two players. Now we will still be using t-test, but it is paired sample t-test. Paired sample means related sample t-test because we are testing the average person. They must be related. So we will be using paired sample t-test. Now, if it is possible that let's test what is the difference or is there a difference between these three golfers, like the average drive distance of dolly, average drive distance of lorry, average drive distance of male, are they different to each other? If we test this, then we will be using ANOVA, analysis of variance. Now, what's the difference between t-test and ANOVA? In t-test, you have two variables or two groups. If we have multiple variables or multiple groups, I mean more than two, then we're still testing the test of difference. However, we use ANOVA because we have more than two groups. Okay. Now, the next one is number of drives in fairway. 4 for dolly, 22 for lorry, and 11 for male. Now, the hypothesis is male drives the ball more accurately than dolly. Now, carefully look. What is our hypothesis? Male drives the ball more accurately than dolly. So now you do not have any interval or ratio variable, like you do not have distance. What you have is first a nominal variable golfer, that is molly and dolly, and the other variable is accuracy, like nominal. It's also nominal, like right, fairway, and left. So both the variables now are nominal variable. One is golfer, male, and dolly, and another is the accuracy, right, fairway, and left. So when you have two nominal scale variable, you should be using chi-square test. Okay, so this example is important. That gives you an idea that under what circumstance what test of difference should be used. So this is the end of discussion on learning objective 1. Please see the next video for a discussion on this week's learning objective 2. Thank you.